So good morning. My name is Susanne Balle. I'm from Intel, and I'm going to talk about how you can actually optimize resource consumption and utilization in your openStack cloud. This is actually a community work, and so this is why, as you see, we have a joint work with BCom and IBM. So what I want to talk to you today is about Watcher. Watcher is an openStack project. We started it in September. We're planning on putting it under the openStack big tent as soon as we get back. We talked to various people and believe we're ready. And what the Watcher is providing is really a flexible framework for operators to bring in telemetry through either Ceilometer or Monasca. And Watcher can consume it and optimize it based on constraints or machine learning algorithms and optimize your cloud. So if you look at what we have in Watcher, it's really a framework to optimize your cloud for various goals, and it's pluggable. Right now, we already out there in GitHub have energy-aware optimization, for example, outlet temperature. We also have a different algorithm around VM rebalancing. And I think one of the things that is important here is that because it's an openStack soon to be under the Big Ten project, we're talking with a lot of people who are now coming in and contributing around their use cases. And so the more operator or people running large-scale clouds or even small large clouds, but want to rebalance their workloads, the better the use cases. One of the reason we originally came up with this, or was wanting to do something like Watcher, was because we've all heard of the example where people use Amazon, start up the VM, run a test, realize that they're on either a small server or they have a bad neighbor, kill it, try it again. And so one of the reasons, one of the things Watcher can do, it actually makes the initial placement less important. It's still, initial placement is still important, but you never know what kind of neighbor that you're going to end up with later as the cloud gets filled up. And also once you have a pretty close to full cloud, where do you place workloads so that your workload can actually meet the SLAs and the QSs? And this is really where Watcher comes in. If you look at, so originally back in September, IBM, BCom, and Intel got together and we decided this is something we need. Since then, we actually have contribution from many more companies, and we're growing really fast. And so I really want to make sure that, and we, of course, that you guys knew about Watcher because it's not that well known as some of the core project, but we're really getting there and we're having a lot of momentum. So right now, some of the key features as the code is today is we're doing, like I said, several cloud optimization around VM live migration, where we detect imbalance. And I'll give you a list of some of the algorithms we have. We have many more in the pipeline. And again, one of the things coming from Intel that I'm interested in is also what are the telemetry that people are interested in seeing in, for example, Ceilometer and Monasca, so that they can create their own algorithms. Right now, so again, going back to the whole framework thing, it's flexible. So we decided that we are actually, open sourcing some of our algorithm. If you decide you want to do algorithm and not open source them, that is also something that is totally up to you. We have both type of contributors. So Watcher can run in several modes. So you can kind of imagine that you want to optimize your cloud, and the first thing you want to do is really just figure out, how bad is my TCO, or how bad is my cloud currently, balanced. And so you can actually trigger it to Watcher to come back with an action plan where it kind of says, if you move this VM over here, you would actually meet this SLA. And so you can actually, and you know, where some of the examples that we have are, for example, Intel had a customer where they were looking at trying to increase the temperature in the data center, figuring out, you know, what that would mean. And so we looked at the specs for the servers, and the server was fine, but then suddenly realized that some of the cables behind the server, the outlet temperature was getting too hot. And so in some of those examples, you know, so those are some of the algorithms that we put in here. So getting back to the advised mode versus the active mode, advised mode is where you trigger Watcher to do an optimization based on the algorithm that, or the SLAs that you have, and then it comes back and tells you what you need to do. The other one, there is also a mode which we call active mode, where you can kind of, as you get more and more used to Watcher, you can kind of imagine that you are going to see a lot of the same options or actions being offered to you, like move this VM with this workload over to a different node. And so you can kind of choose, in some cases, to just use what we call the active mode, which is that it happens automatically. In that case, and again, based on, you know, what algorithm you have in there and what actions are being recommended, the plan is to eventually be able to do that automatically or manually. So where does Watcher fit in the ecosystem? And I've mentioned it several times. We are like 100% openStack compatible in terms of we're using the same processes, we have weekly meetings, we have IRC, and you know, and we're integrating at this point, you know, with Nova, Keystone, of course, Oslo, Ironic, Celameter, and we are currently talking with the Monasca team to make sure that we can actually pull the data out of Monasca as well to do some of this. And the goal of Watcher is really to be able to have the operator look at their cloud and say, okay, how do I optimize? How do I reduce the total cost of ownership of this cloud? Either by, you know, putting VMs on more, you know, on kind of stacking VMs or bin packing VMs, or you know, also looking at some storage metrics. Most of the metrics that we're currently looking at are very much CPU related or server related, but we can imagine algorithms in the future where we actually get metrics in from the storage and rebalance workload based on that as well. So in terms of you know, the workflow, if you look at what Watcher is doing, so Watcher has a cost model, an objective, and of course some constraints, and those are kind of fed into what we call the decision engine, and that is where we actually have the plugins. And what that piece is doing is it's finding the trade-offs between the objectives that the user kind of has in terms of quality of service and the constraints, which are what are the nodes that are available in your cloud and what are the, you know, so what is fitting where. Then once it's kind of done this type of analysis, it's going to come up with a plan. And the plan there is going to be, you know, what are the actions that needs to be performed in order for you to get a better performance out of your cloud. And it could just be, you know, as we know, most of the clouds are, 50% utilized, most of the servers are. And so just doing maybe a bin packing or, you know, or changing the way things are being allocated can increase the utilization of the cloud. That might allow you to only have to cool down a certain area of your data center versus having to kind of cool down. And so those are some of the things that we're also looking at. So once you have the plan, then you need to apply it. And so, like I said, at this point we have two modes, the action plan, or the manual, and the auto mode, where you can have Watcher do it automatically, which is still under development. And then, of course, you know, we are bringing in all those metrics from either Celameter or Monasca, But we also are bringing in some of the telemetry that we're looking at from, for example, the platform itself. So, and then, we analyze, we have the notion of also kind of real-time monitoring, where we can actually look at a stream of events and do anomaly detections or other things, as well as having the notion of doing kind of more advanced algorithm and machine learning. So more than just doing a threshold or looking at the data. So in terms, and this I realize now is quite of an eye chart, but this is kind of the history of Watcher and where we're going. And like you said, we started out small. We have a lot more contributor now, and a lot of interest from even what I would say large companies that are running large cloud, where they realize now they finally have OpenStack up and running. Now what? How do we optimize it? And so as you see, we started in November of 14. Then September of 2015 is when we started a small group. And after that original meetup, we kind of decided, okay, now we want to be part of OpenStack, and let's start using the OpenStack processes. And at this point, for the Mitaka release, we have several new strategies, as well as DevStack integration. So if you need to if you want to take Watcher out for a spin, it integrates with DevStack very easy, and so you can also set it up in your real cloud, but if you just want to try it out, DevStack is fine. Some of the things that we have for the next release is, again, more strategies, a little hardening of the infrastructure, but I think the biggest part here at this point is that we want to be part of the big tent in OpenStack. So if you have any questions, so I was told no questions today, but we can meet outside. And we're definitely looking for more contributors. And we have a longer sessions where we're actually going into more details in Watcher around also the architecture and what are our various deliverables for the next release. And that is on Thursday at 2:20, actually also in this level. So that. I hope you enjoyed this talk, and that now you are aware of Watcher and its existence, and that you will join us in contributing. Either join us on IRC, and we always welcome new faces. Thank you.